Guys, welcome to day 12 of the 28 days data science AI and Gen AI challenge. So today I'm going to give some time and try to explain you a concept called optimizer. What is the importance of the optimizer in neural network? Optimizer as a concept is not there in machine learning, but optimizer plays a very important role in neural network. So let's try to understand what is optimizer, what are different types of optimizer. At the same time, I'm going to give importance on optimizer called Adam optimizer. Okay, so let's go ahead. This is something which I have done for the first time. I put forward what is the agenda of the things in this video. So I'm going to introduce the neural network, which you already know. What is the training process in neural network? What is the backward propagation? What is optimizer algorithm? I'm going to give some importance on gradient descent, explain the Adam optimizer, how does it works, what is the benefit, and what is the conclusion of this. If you want, you can increase the speed of this video to 1.5x2. Okay, I think I speak pretty in a decent frequency, but if you feel I'm a bit slow, you can always increase the speed. Now, neural network is technically a network which tries to mimic neurons within the human brain. I put forward the diagram of a neuron. Axon is nothing but the output of it. So when you get an input, it processes it and then gives you an output. Something similar to what we have in a neural network. Okay, so basically a neural network can be used for speech to text. It can be also used for image recognitions. There are so many applications of it. Okay, the key component what I have put forward is that it has neurons, it has weight, it has bias, it has layers and all. Okay, so let me try to explain with the proper example. Okay, so now here I'll try to put forward some neurons. Okay, so in a given neural network, it has a neurons, assuming that it has 3 input features, and then it has 2 neurons of a hidden layer, and then assume that it has 1 output layer, okay, with 1 neuron. So what happens theoretically? So all neurons are interconnected to each other. Okay, so this would also connect to this would be also connected to this. So this is nothing but your input layer. This area is called the hidden layer. This area is called the output layer. Okay, now every input, let's for example, this is my input x1, x2, x3. Every input would also have something called weights. Okay, now what happens in every neuron is that there is an aggregation of all the input multiplied by the weights. Okay, and then every neuron would also have something called an activation function. So when we do all this process from end to end, technically what is happening? A forward propagation is being done. Okay, after that, after forward propagation is being completed, so at the end we are going to calculate what is the difference between y minus y hat, which is nothing but the loss function. Okay, based on that, this is the loss calculation. Based on that, we will try to understand that if we want to go back, if we want to improve any kind of errors, what kind of errors we have to, what kind of weights we have to update. So this process of going back is called a backward propagation, and that's how this process goes on and on and on, and the optimization happens. Okay, so at the same time, how does this weights gets updated and all, I'm going to talk about that with the help of the optimizer techniques. Okay, so this is the concept of backward propagation. I have again put forward into the context. So it computes the loss, it calculates the gradients, it updates the weights and biases, and then it repeats the process as it goes. Backward propagation, as I have explained in yesterday's challenge, it is a very important concept. It is a very unique for neural network. Try to understand that too. If you have any kind of questions on previous video, please let me know. What I will do, I'll try to add the previous videos link in the description too. If you want to go and watch, please go and watch too. Okay, now coming back to what is a optimizer. Okay, optimization algorithms are technically there are many optimization algorithms. I've put forward two optimization algorithms called gradient descent and Adam. Okay, the idea of the optimization algorithm is to find the most optimal model as soon as possible. You can put forward like that. Now, gradient descent is a very common kind of optimizer, which is also available in machine learning model, but technically it is not inbuilt within the machine learning model. We have to keep finding the optimal model, which uses gradient descent as one of the optimization techniques to find it. Okay, so optimization, so you can put forward that gradient descent is nothing but an optimization algorithm used to find the local minima or of the function to technically to get the optimal model behind it. Okay, so it computes the gradient, it's updates the weight, it iterates. Let me try to explain with the help of an example. Let's say you have something like this. Okay, imagine you are hiking down. Okay, now your idea is to reach to the most lowest point, which is this part, okay, and and it's very dark, you only have a flashlight. So what are you going to do? You're going to be very cautious. Okay, you're going to take very few steps, and then you're going to make sure that you reach the lowest point of it. Okay, the same side, what does the gradient descent does is that it tries to carefully take steps downhill, tries to adjust the directions as so that you can reach the lowest point of it. Okay, so in gradient descent I can have a learning rate, which what it will do, it will try to find the lowest point like this. Okay, if the learning rate is not proper, what is going to happen? It is going to get lost and won't find the optimal point. We try to use a different color. It's going to lose and not going to find the optimal point. At the same time, you have to be very balanced. It cannot be very small. It cannot be very big too. Okay, so if you understand gradient descent, let me try to explain what is the issue in the gradient descent and why we have to go ahead and try to find a model like optimizer model like Adam. Okay, so Adam technically is an abbreviation of the Adam is adaptive movement estimation. Okay, in case, let's say for example you have something like this. Okay, you have a slope like something like this, and happen to be you can see there are two minimum points, but this is not the global minimum. So basically this is the global minima which you should reach, and this is one more minima, which is technically what happens if you're using gradient descent. It's going to go there and going to get stuck there. Okay, Adam optimizer on the other hand, what it does is that it tries to not only use the concept of learning rate, it also uses a concept of momentum. Hence, because of that, it goes ahead and try to find the right global minima too. Let me try to explain with the help of taking the same example. Okay, imagine that you are using, so this is the same example. So what happens is that in this is that Adam uses a concept called momentum. Once it comes and reaches here, right? So what happens is it knows that this momentum is very, very steep. So it accelerates the optimization of process and it reduces the oscillation during the training, and the resultant is that it goes ahead of this and reaches the global minima. Okay, so technically two things happens here. It is because of the momentum as well as the concept of how I'm going to avoid the local minima. Okay, the momentum helps the Adam optimizer to go ahead of it and push past the local minima and tries to reach the global minima. Okay, so always remember the concept of momentum is very, very important in terms of Adam optimizer. At the same time, we also have the same learning rate concept here too. So combination, Adam plays a very important role in the whole optimization stuff. If you understand this, technically You understand that because of Adam, we are able to do a fast convergence, we are able to do a stable learning, we are able to do a wide, and it is widely used across the board. Okay, so if you want to put forward any kind of neural network, happen to be the first optimizer they will try to use is Adam. Okay, it's very quick, it's very stable, it's easy to use, and whether you are training neural network or any kind of image recognition stuff, Adam would be the most preferred optimizer technique. Now, in terms of conclusion, what I'll say is that once you understand all these concepts, because I think so, I have taken good amount of time to explain what is a neural network, what is activation function, what is optimization, created the whole thing with the help of the code. I'm going to show you the code of Adam too. Okay, go ahead, go back, try to use this code and try to create your first neural network. And if you have any kind of question, please come ahead and ask me. Okay, thank you. And here I'm showing about the optimization in the neural network. So technically I have reused the code what I have shared you yesterday, the breast cancer data set. Okay, so before I go ahead and talk about the code, if you can see in my first line, there is a Discord server link, documentation link, YouTube link, and LinkedIn link. Please go ahead, and if you have any question, this is not the only space where you can ask question. You can ask me question in LinkedIn. Please do connect with me and ask in the Discord server. Okay, so something similar what I have already shared yesterday. So I have divided the whole product in different cells, putting forward a title so that you can understand what's going on. So import libraries, load the data set, make sure that you do the pre-processing of the data set, for example standardization and train test split. Okay, the only thing which I like to add is that you see yesterday I have used gradient descent as one of my optimizer. Today I have used Adam. I have not changed anything in the program. Technically I've just added one more lines of code for the Adam. Okay, so when I'm creating the sequential network, I've created something similar for Adam 2. Okay, then I've compiled it, then I've trained it. Now if you see very clearly, okay, when I'm doing with the help of gradient descent, the things were trained in 8 seconds. When I use Adam optimizer, the things were trained in 7 seconds. I know 1 second is not a very big game changer, but try to understand it is not a game changer for this small data set. But when you're using a larger data set, this 1 second can be few minutes can be few hours also. Okay, it's an upfront example that Adam optimizer is amazing in terms of optimizing the network, right, and finding the right model instantly. So I visualized it. This is something which you would have already known in yesterday's example too. Nothing has changed, everything is same. Now when I go ahead and try to put forward for the Adam optimizers output, you will see that in terms of training and validation accuracy, Adam optimizer instantly gets 100% accuracy in the initial epochs itself. Isn't that amazing? If you see here, gradient descent doesn't get 100% instantly. It does get somewhere around 100%, not even exact 100%, somewhere around 20th or 30th epochs only. But here it is getting 100% instantly. Okay, that is one thing. At the same time, it's very important to understand in terms of loss. If you see loss, the training loss is gradually increasing. At the same time, the validation loss, the training loss is constant. It's constant, but the validation loss is constantly increasing. What does it means that somewhere our model is overfit? The reason behind the overfit is not the optimization technique is bad. The reason behind the overfit is because we don't need so many epochs for Adam optimizer. You can technically reduce the number of epochs, and because the data set is smaller, that's why there's a very good chance it can overfit. Hence, Adam optimizer, if you want to use it, technically if you have a bigger data set, it's much better. Beyond that, you can use techniques to reduce the overfitting with the help of regularization, also the L2 regularization. So this is something which you go back and try to redo it at your own space. Okay, if you have any questions, please do come forward and put forward a comment. Happy to explain. Okay, and please do subscribe. I can see that people are viewing the video but not subscribing, please do go ahead and subscribe. It gives a lot of appreciation to the things what we are doing right now. Okay, thank you. If you have reached till here, it means that you have finished the video. Thanks for watching and being part of the 28 Data Science Challenge. Your support, engagement and enthusiasm make this journey even more exciting for me. If you found this valuable, drop a comment, share your insight and tag a friend who should join us. Let's keep learning, building and growing together in the AI and Gen AI space. Make sure to like, subscribe and stay tuned for the next challenging stuff what is going to come tomorrow, because we have just started and it is going to get better and better as we go. Bye.